Hey everyone, and welcome to our lecture on for loops. So what are for loops? It's just another type of loop. So we learned previously about the while loop. This is another way to write loops, and it has certain use cases that we'll get into. So the typical use cases are iterating over elements in a container or counting loops. So we did several loops with the while loop where we would be counting something, or essentially making the loop body happen a certain number of times. And it turns out that for loops lend themselves very well to that. So how do we write a for loop? Well, the syntax looks like this. It uses the keyword for, and we have this variable in container, and we'll get into what this is, followed by the body. And the body, just like our other control structures, has to be indented. By convention, we indent 4 spaces. Okay, so what did I mean by for variable in container? So a container, just to recap, is a data structure that contains other data structures or data elements. So students is a container, and it contains 3 students, Alice, Bob, and Charles. Each one of those are strings. We can loop over every element in this container by saying something like for student in students. So student is a variable that I just created. Notice it hasn't been created before now. And what's going to happen is on each iteration, the for loop is going to start at the beginning of the list, and it's going to assign the current element to student. So for that iteration, student will be Alice. When it comes back around, next time student will be Bob, and it'll print student. And then the next time it comes back around, student will be Charles, it'll print student. And it'll come back around and see that it's looked at every element in the list, and it'll leave the loop at that point. So we can see down here below, this is our execution. We have Alice, Bob, Charles, and then done. If we wanted to do that same thing with the while loop, there was a few things that we would need to set up. We'd need to set up our loop control variable on line 5, so I equals 0, and it's 0 because that is the representing the index position of the first element in the students list. So indexes start at 0, so that's where we start. And while I is less than the len of students, so while I is less than 3, do this. Pull out student, student equals student sub I, print student, and then modify our loop condition. Alright, so hopefully you're starting to see the benefit of taking something that would have looked like this and simplifying it down to this. It's just a lot easier to read. Functionally, though, they are the exact same. Okay, so that's for loops in a nutshell. With the for loops, there's several different functions that we can use depending on how we want to loop over those elements. So one of them being reversed. And what reversed is going to do is it's just going to loop over that container, but it's going to start at the last element and work its way up to the first. So looking at an example of that, same thing here. We just reversed students. So for student in reversed students, print out the student. We can see it goes Charles, Bob, Alice, and then done. Another function that we use a lot with for loops, and this one's particularly useful when we're doing counted for loops, is range. So range only requires one argument, but there's 3 different ways that we could call range. And you can see those listed down here. One with 1 argument, one with 2 arguments, and then there's a version of range that we can call with 3 arguments. So let's talk real quick about what these 3 would be useful for. Well, if we just use range and we pass in 1 argument to represent where we want to stop, like if we go range and pass in a 5, then it's going to generate the numbers from 0 to 5 minus 1, so 4. Now just so we're all on the same page, let's take a look at what that looks like in idle. Okay, so we can do this here in the interactive prompt. We're going to use this in a for loop. So remember, the syntax for a for loop is for some variable in a container, and our container this time is going to be this range function. So it's going to generate a container for us. So range 5, and let's give this a more sensible name. Let's call this for num in range 5. Let's just print num. Okay, so if we execute that, we see that on each loop body, each iteration, num was given one of these numbers from the range. So it started at 0 and went up to end minus 1. So 5 minus 1 is 4, and that's why we stopped there. Now, if we didn't want to start at 0, then we could use this second version here where we specify a start. So let's say for num in range, and instead of starting at 0, I want to start at 2. And I want to go up to but not including 5. So stopping at 4, print num. Notice that we started at 2 this time, then we went 3 and 4. And then lastly, there's this other version where we can specify a skip. So what you'll notice is we're just adding 1 to the previous number each time, and we're getting the next number in succession. If we don't want that, maybe we want every other number, then we could use that as our skip. So quick example of that, for num in range, starting at 2, going up to 10, and looking at every other number would have a skip of 2. Let's print num. Okay, 2, 4, 6, 8, up to but not including 10. All right, so that's a great way to get things like just even numbers, or if we started with an odd number, we could get all odd numbers that way. Starting at 1, going up to 10, and skipping 2, print num. We get 1, 3, 5, 7, and 9. Okay, so there's couple more screenshot examples of that. I guess another a good point to make here is that you can skip by -1 if you want to go in reverse. So on this one, we started at 5 and we went down to 0, but not to 0 all the way. So just 1 off from it, which is why it stopped at 1. And we skipped by -1. So on each iteration, we were adding -1 to the previous number, and that's how we went from 5 to 4 to 3 to 2 to 1. Alright, so now we've been introduced to 2 different types of loops. How do we know which one to pick for what sort of situation? And there's some general guidelines that we can use. When possible, we should try to use a for loop. So when the number of iterations is computable before entering the loop. A great example of that is counting. Even though we may use a range function or something to do that counting, it's predictable how many iterations we're going to need to do. Another good example of when to use a for loop is when we're accessing elements of a container. So going back to our original example, when we were doing for something in a container like students. It's just easier to write our loops this way. It's easier to read through as well. And there's less maintenance because we're not having to initialize a loop control variable, modify it, or pull the element out manually. All of that's getting done for us here in the for loop. So when do we use a while loop? Well, we use a while loop when we don't know how many iterations we're going to be doing. So great examples of that would be sentinel values. Give me an arbitrary list of something and then -1 to quit. Well, I have no idea how big that list is going to be. So I can't do a for loop with that. I have to use a while loop. So with both of these types of loops, there's some special keywords that we're allowed to use inside them. And one of those keywords is break. And what break does is it causes a loop to just go ahead and immediately exit. So usually we write our loops to where the condition will become false, and that's how we exit. But sometimes we have other weird conditions that maybe warrant the use of a break statement, so that's why we have it. And it can just make the logic easier to understand. So like I was saying, we can do this with a for loop or with a while loop. And essentially it's just the word break. We put that in our code, and if it hits that word break, then it's going to leave the loop and continue execution after the loop body. So let's see an example of that. So here's a good example where we are looping over the numbers 1 to 99. So for I in range 1 to 99, print I. And we can see it's printing I, 1, 2, 3, 4, 5, but it doesn't go all the way up to 99. And it doesn't because of line 5 and 6. So on line 5, after we print I, and let's say that I is 5 this time, if I equals 5, then we go into this if statement and we break. So when we break, we leave immediately, and we start executing the next line after the loop body, which is this print done. Alright, so it's a way that we can preemptively exit the loop before the loop condition becomes false. So look at this example. Kind of silly, although we may see this used sometimes. So while true, this is an infinite loop. This will never become false. So this is a literal, it's a Boolean literal, true. We'll never change that. It's not in a variable. We have no control variable here for this, so we can just start counting, starting from 0, printing I, on each iteration adding 1 to I, but since there's nothing in the condition here to make this become false, it's just going to count up to essentially infinity, or we run out of memory or something like that. Well, as soon as it hits 5, it's going to break anyways, so this actually just went from 0 to 5. Just like our last example. And then sort of going along right with that break keyword is another keyword called continue. And what continue does is it's sort of like break, but instead of leaving the loop altogether, it just leaves the rest of that loop body and goes up and reevaluates the condition again. So essentially just skips the rest of the current iteration. This can also be used to improve readability. We could get around this. We could put things in if statements and have some sort of deep nested logic going on, but continue just makes things a little bit easier. And again, this can be used with both types of loops, while or for. So the keyword is continue, and we would use that wherever we would like to have it continue at, just like with the break. So let's take a look here. And so on this one, we're counting from 1 to 4, and we're printing out I on each iteration. But if I equals 3, I want to continue. So as we step through this, and I'd encourage you to type this code out and put it in the Visualize Python website so that you can step through it as well. But we can see 1, 2, and then when I equals 3, it continues. So it skips over the rest of the iteration and comes back up and gets a new I, and it prints out 4. Okay, so big takeaway here is continue will let us skip that iteration. So additionally, there's this notion of a loop else, and Python's sort of unique in this, in that most other languages don't have an else that can be associated with a loop. But Python does, and we can use this again with for or while loops, and it's really similar to how we use the else with an if statement. Basically, as long as the loop terminates normally, meaning we don't use a break statement, the condition just becomes false, then the else body will execute. Okay, so let's look at the syntax for that. looks something like this, very similar to our if statements. We're just using them with loops instead, so while condition. And then on the same indentation level as the while, we can have an else. Same thing here with the for loop. We can have the for, blah, blah, blah. And then on the same indentation level, we can have an else that only gets done if we leave this loop naturally. Okay, so let's look at an example of this. If we have a container, numbers, and it contains, in this case, 1, 2, 3, 4, we can loop over these numbers using a for loop, so for number and numbers. And then if that number is less than 0, so if it's negative, then print out that you found a negative and break. Okay, so if we break out of this, then we will not do the loop else, and we will pick up execution here on line 11. We could pretend like there was something there, like a print done or something, and that would execute. But if we iterate through all of these numbers and we never go into this if statement, then we're going to leave our loop naturally. Okay, so we will have looped over all the elements, and then the loop else would execute, and it would print out no negative numbers found. So in this case, since there are no negative numbers in the list, it prints out no negative numbers found. Now, what I'd like you to do is take this and type it up and put it into the Visualize Python website and step through it. So step through it this way, and then step through it again, but change what the list looks like and put in a -3 in here, populate it with some more numbers, and see what happens so that you can understand the flow and when the else body will actually execute. So there's an example of that. We changed this to -3. In that case, it prints found a negative because -3 is less than 0. It breaks, so it skips over the else, and it's done with the program. All right, so one more useful function that we can use with our for loops is enumerate. And what enumerate does is it loops over a container like a list or a tuple, and it'll return a tuple on each iteration. So that may sound confusing, but it's really not. What it's returning is the index position and the value from that position. Okay, so let's look at an example. I think that'll make a lot of sense. If we loop over this, and let's say we wanted to actually get the index position of each one, without enumerate, the way that we would have to do it would look something like this. We'd have a students container, Alice, Bob, and Charles, and then we would do a counted loop. So we're going to count over the range of len of students, so that's 3, and we know that it goes up to but not including 3, so this is going to go from 0, 1, and 2, which happens to match up to our index positions, right? So then we can pull out the student equals student sub I, and then print out whatever I is, so the index position and the student name. All right, we can simplify this if we use the enumerate function. So with this one, what we're doing is we're saying enumerate students. So on the first iteration, what it's going to return to us will be a tuple, and that tuple would look something like this. It would be 0, Alice, and then on the next iteration it would be 1 and Bob, and then on the next iteration it would be 2 and Charles. So we see that that gets returned as an enum tuple. Enum tuple equals that is basically what's happening. And in the loop body, we're pulling out the individual values from this tuple. So we're saying that the enum tuple sub 0, which is this position in the tuple, equals I, and the student is at position 1, right? Enum tuple sub 1 is Alice. And then printing that out. So that all works just good, and that's a little bit cleaner looking than like this. although it does involve an extra line here, there's one other way that we could sort of clean this up and have it work a little bit, or have it look a little bit easier. And that's using something called tuple unpacking, which we'll formally introduce here on the next slide. But look at the syntax here. So for I, comma, student in enumerate students. Go back to my text editor here. And let's just look at this. So this is saying, on at least the first iteration, that I, comma, student equals the first values enumeration, so 0, comma, Alice, and it's using something called tuple unpacking. So when we unpack a tuple, we list a bunch of variable names, okay, and these variable names are separated with commas, and it has to line up to the same amount of elements that we have in the tuple. And what happens is I ends up being 0 and student ends up being Alice, because positionally they're in the same position. And it's just sort of this magical, nice feature that Python provides for us to save us from having to do something like this on line 6 and 7. Okay, so we can clean that up, make it easier, and you can see the loop body now is just one line, this print index position student name. All right, so 3 examples, all functionally similar, or functionally the same, really, because the output is the exact same. But the complexity of the way it was written changes. So this one probably looks like the most. It is leveraging the enumerate. This one is not using enumerate. We're still having to pull out the student. And then ultimately we have this one that's using the enumerate and tuple unpacking to make the code very concise and condensed. Alright, so what is unpacking again? Well, formally that is something that performs multiple assignments at once, and it's assigned from left to right in order. Okay, so if we have a tuple like values, 1000, Alice, CSCI 135, so here's our tuple, we can unpack that by creating 3 different variables, separating them with commas here, and setting them equal to that tuple. That's going to effectively unpack this. So 1000 will get assigned here. Alice will be assigned the student name. Student class will be CSCI 135. And just to prove that, we printed it out on lines 6, 7, and 8. Lastly, I just want to talk about a common strategy when we write programs, and I think I've been hinting at this all semester, but just to reiterate it, we want to do incremental programming. So we want to start with a really simple version of our program, and once we have that simple version working correctly and we've tested it out, then we'll start growing it little by little, and we'll add some more complexity to it. And as we add that complexity, we'll test it and make sure it works. And when it does, we'll add a little bit more complexity until ultimately we get to the completed version of whatever program it was that we were trying to write. So let's look at an example here real quick. Let's write a program that first asks the user to type in today's price of $1 in Japanese yen, and then reads the US dollars values and converts each to Japanese yen. And we'll use a 0 as the sentinel value to denote the end of dollar inputs, or basically we're done running the program at that point. Okay, so I would start off by just prompting for the dollar to yen, so that conversion amount, and then prompting for a dollar amount, and then figuring out what the converted amount would be. So just doing the simple multiplication of that, and then telling the user, outputting back to them what that converted value would be. So notice I didn't bother messing with a loop here in this condition. I just wanted to go through and make sure that I had the logic right and that I could correctly find the converted value and take in those inputs, etc. So once I test that and I know that it's working, so I could test that and I would probably test it multiple times. Okay, but here's an example of one test where at this particular day when I ran it, the conversion was 113.75 yen to $1. And if we have $3.50, well, our program does the multiplication and tells us that our $3.50 is really 398.12 yen. Okay, so once I feel comfortable with that, then I would come back and I would modify my program to do that loop using the control or the sentinel value as my loop control variable. So while the dollar amount does not equal 0, that means I want to keep doing something. So I've already got a dollar amount here on line 4. Hopefully they didn't enter 0 for that, but if they did, it just wouldn't do anything. As long as they entered something, then it's going to figure out the converted amount, print it, and so our loop has a chance to become false. We grab a new dollar amount before we come back up. All right, so this should allow our program to keep going. Maybe we have multiple conversions we want to do, so loop makes sense in this case. And what we can see is if we put in that conversion amount in 350, we get what we got before, but now it's giving me the chance to convert something again, like 1050, and I can see how many yen that is. 13, and I can see how many yen that is. And then ultimately I'm done and I'll put in 0, and that's when this would become false and we would leave the loop and exit the program. Alright, so that's it for our chapter on for loops. Hope you enjoy the labs and the exercises. If you run into any problems or questions, please feel free to reach out to me. If not, I'll see you guys in the next video. Thank you.